Okay, welcome. So now we're going to get into operations of functions. And what I have devised here is a little bit of a warm-up just to kind of get us prepared for the operations of functions. So this is going to be evaluating functions, which something obviously coming into this lesson should be something you're familiar with. And then I'll talk about the different operations of functions. And also we're going to discuss, finding the domain after we've applied the operation. And that's really the main thing. In Algebra 2, we talk about operations of functions, but we're going to kind of bring in a mix of how the domain is affected when we apply those operations. But first of all, I just want to kind of get through the evaluating of functions because some people forget or some people start making mistakes, and this will help us at the end of this lesson to kind of refer back to. So what we have is we're just evaluating our function f of x for these given values. And you can see here f of x is x squared minus 2x plus 1. And basically what we're going to do is just find the value of the function for each of these different inputs. So let's go ahead and get into the first one. This is going to be f of 1. Let me change here. Let's just use black here. So f of 1, all we're going to do is now replace the x's with a 1. So therefore I can just rewrite this as 1 squared minus 2 times 1 plus 1. And then from here, all we're simply doing is just going to be simplifying our expression. So a couple of these I'll, kind of work, step by step, and then I'll start kind of going a little bit quicker. So we have 1 squared, which is just 1, negative 2 times 1, which is negative 2, and then plus 1. And now you can see here, I can, group the 1's together. So 1 plus 1 is 2, and then 2 minus 2 is 0. So you can write your answer like that, or formally we can rewrite our expression, basically saying that the value of our function f at 1 is equal to 0. Let's go ahead and do 0 here. So again, when I'm doing this, what I like to do is always put in parentheses. Even if it's a very basic one, even if I can do it in my head, I like to write out with these parentheses because what we'll see is parentheses become very important, especially when we're applying, evaluating. That's telling us that we're plugging one function, or, in this case, a value into the other. And that's where a lot of mistakes can happen in the operations as well as evaluating functions. But here, I'm not going to, break down this. That becomes 0, that comes 0. So therefore, we're just going to be equal to 1. And for time purposes, I'm not going to rewrite the answer, even though typically that's the way that you would want to, represent your answer, at least in my class. Negative 2, now I will work this one out, or at least kind of break this down. Negative 2 squared minus 2 times negative 2 plus 1. An important thing, remember, negative 2 squared basically just means negative 2 times negative 2. So negative 2 times negative 2 is going to be positive 4. This is actually the same result, so that's going to be plus 4 plus 1. And therefore, that's going to be 4 plus 4 is 8, plus 1 is going to be 9. And sometimes, actually, I have to, say it out loud. I'll write this one in here. Sometimes I have to say it out loud anyways, just because I'll make, a little mental mistake. I don't know why I'm going back to this, but whatever. I'll make a little mental mistake, so that's why a lot of times I just like to say it out loud. And even if I do say it out loud, it's, maybe sometimes faster for you guys to catch on. All right, so now we're going to get into adding in some values that are not, numbers. But again, the process is going to be exactly the same. So the next couple examples are not just simple, integers. We're now going to be plugging in some variable. So here we're going to evaluate the function for f of negative x. So that's exactly all I'm going to do is I'm just going to plug in a negative x. So I just plug in a negative x squared minus 2 times negative x plus 1. Okay, so now negative x squared is negative x times negative x, which is just going to be a positive x squared. Negative 2 times negative x is going to be a positive 2x, and then plus 1. So now you can see we have this nice little trinomial, which is very similar to the other one, but you can see there's a change in signs, and that's going to be something that comes up later in this section. All right, for the next one, we have f of t. Well, again, if you have a different variable, it doesn't really matter what the input value is. Just, go ahead and plug it in. So if I plug in f of t here, f of t, there we go. That's just going to be replacing the x's with t's. Plus 1. And there's really nothing else I can do to simplify this, so I'm just going to rewrite it without parentheses. I like to do the parentheses just to know that that's the operation that I'm applying, but then again, there's really nothing else I needed. You could do a letter and a number, like in this case, it's 3t. So again, we're just going to do the exact same work here, 3t squared, minus 2 times t, put those in parentheses. Oops, I'm sorry. That's going to be minus 2 times t. The t is in parentheses, plus 1. Now 3t squared is 3t times 3t, which is 9t squared. Negative 2 times t is a negative 2t, plus 1. So that's what f of 3t equals. And the last one is, or not the last one, we have an expression, x plus h. This is something that it's going to come up later in the year, so it's a good way for us to kind of see what is exactly happening here. But again, just apply the same operations. Just plug in x plus h in for x of the function. So therefore we have x, plus h squared minus 2 times x plus h. And you can see the pattern that I have here in each of these cases. All my inputs are always inside parentheses. Now I will do a little work here on the side. Remember that x plus h squared is just x plus h times x plus h. Okay, so when I'm multiplying this, I'm going to apply the distributive property, or you could think about it as like FOIL. So therefore I will have, let's go ahead and write that out. So x times x is, let's write it down below. So that's going to be, x squared, h times x is hx. X times h is going to be xh, and then h times h is h squared. Now the important thing is, remember, it doesn't matter, by the commutative property, x times h or h times x, you can just, rearrange them. 3 times 4 is 4 times 3. So we can combine these, and so therefore I have 2 of them. So my expanded form here is going to be, it's going to be an x squared plus 2xh. Doesn't matter if you want to write xh or 2hx, doesn't matter. Here I need to apply the distributive property, so that becomes a negative 2x. Negative 2 times h is a negative 2h plus 1. Now none of these are like terms. They don't all have the same variables, like exactly the same variables and power, so therefore I can't combine them. They have to be the same base variable as well as have the same power. So there's really nothing else I could do here. That is just going to be my finalized expression. And then the last one is just going to be composition. Now this one, I'll get to the word composition here in just a second. But you can see here this g of x. This is now, it looks like a function, but we don't have a function g of x defined. Well, that's okay. For this problem, we are just going to assume, well, we don't know what g of x is, but we're just going to plug it into the function. Like, I have no idea what it is, so let's just plug it in. So I'll have g of x, going to be quite a bit of parentheses here, minus 2 times g of x plus 1. And there you go. I mean, that's basically it. Whatever's the input of that function notation, that's what you plug in into the expression. Now, I can write this out with a little bit less parentheses. You might see this, also represented like this. Might see this represented like g squared of x minus 2 times g of x. Not one notation is, better than the other. It's just another way. I thought I would just write it out there for you guys to see that that represents g of x squared, and this represents 2 times g of x, okay? All right, so now let's kind of get into, our operations of functions. And just like we've talked about operations of expressions, operations of polynomials, in previous courses, basically what we're going to do is add, subtract, multiply, and divide. And then this new one, which I alluded to earlier, where I said was composition. And we'll talk more about composition later. I don't think I mentioned composition right now. No, I didn't. So anyways, if we just want to add and subtract, if I have, this is our function notation, and this is exactly what it represents. So if I have f plus g, of x, that basically just means I'm going to add f of x plus g of x. And if you're subtracting, you subtract. If I do fg of x, that basically means I'm multiplying the two functions. And if I have f divided by g of x, that basically just means I'm taking f of x divided by g of x. And remember our domain restrictions, because again, that's the big thing that we're going to be talking about today, is applying our domain restrictions. And then the last one is composition, which is basically taking a function and plugging it into the other function. Now, the key thing that's going to come up with our domain is, when we're going to apply these operations, we are going to simplify it and do some arithmetic stuff, to make things look nice and neat. But the important thing we have to remember is even though we're applying these operations and even though we're going to get a new function, we have to remember that the domain restrictions still remain. That's what we call our implied domains of our two functions are still going to exist. So when we're writing the domain, we just need to make sure that we keep track of our domain restrictions of each of our functions. And obviously, I will get into that more as we start to get into example 1, which why not we get started.